In this video, we're going to look at calculating the optimal time to harvest. A tree farmer spends $20,000 planting tree seedlings. The value of these trees at year T is given by the following equation. We want to maximize the present value of the tree farmer's profit by finding the optimal time to harvest. So the present value of the farmer's profit is going to be given by the following. Here, this exponential function raised to the minus RT is what we're using to discount the value of the trees at time T. We're going to let the discount rate, or interest rate R, equal 4%, 0.04. I'll make that substitution. So we're going to maximize this equation. Rewriting that equation, and now taking the derivative of that equation with respect to t, get the following result, setting that derivative equal to 0. So we're going to take the derivative of minus 0.04t, and the derivative of that is just minus 0.04. That's what we have out in front there. And then we're going to add to that, this time, the derivative of this mess here. We're going to take the derivative of 0.4t raised to the 0.5. Doing that, you get this result right here. And that's what's placed out in front. Again, all of this is set equal to 0. Moving this chunk of terms over to the right-hand side and noting that 0.4 times 0.5 is just 0.2. I got 0.2 here. Doing some division, we have this e raised to the minus 0.04t over here, and this e raised to the 0.4t raised to the 0.05. That appears on both the left and right-hand side of the equation. They cancel, leaving us with this. And now solving for t. And just raising both sides to the minus second power. T equals 25. So in order to maximize the discounted value of profits, the farmer should harvest his trees in 25 years. One important feature of this optimality condition, we saw this earlier in the last slide, and basically this means trees should be harvested when the interest rate or discount rate equals the growth rate of trees. The value of trees at a given time is given by this, and we saw that at the start of this problem. The growth rate of this value is going to be the derivative of v divided by just v of t. And doing that and evaluating it, it just simplifies down to this, which we see up here. So again, in other words, in order to maximize profit here, the interest rate or the discount rate should equal the growth rate of trees. So for example, if the value of trees is growing faster than the interest rate, the best return would come from waiting to cut your trees. On the other hand, if the interest rate is exceeding the growth rate and the value of your trees, it would make sense to cut your trees and put that money then and invest it at the interest rate that is exceeding the growth rate of the value of your trees. Okay, I hope you found this video helpful.